Yes, Pradyumna. So yesterday we were seeing about the OSPF router configuration. Okay, so today we are going to see about default route advertisement. Okay. So now can you tell me what, in general, what will be the syntax for or to enable a default route on a router? What is that?
Yeah, IP route 0.0.0.
Okay. So here also we are going to use a similar configuration. Okay, IP route only. So default route itself, it's IP route 0.0.0.0. Anything, okay, with any subnet mask, with any IP. Okay, so we are going to map it to a specific destination. Okay. Example, okay, 164 1.2 as an example. So this is a default route which we are going to enable. And how we are going to inject this default route into the OSPF. Okay. So how we are going to inject this default route, or what is the necessary in order, why what is the necessary to inject this default route to OSPF? That is also we are going to see today. Okay. So I'll share one Word document. Yeah, so in this example, so just forget about this internet cloud, okay? So earlier we've seen R1, R2, R3 networks being connected in single area. We've enabled OSPF configuration. And also we have seen a sample outputs also, how the networks or the network advertisement is happening. Now, in the R1 router, okay, there's a internet connected behind the firewall. So that means any users inside this network or inside the office of R1 or R2 or R3. Okay. So R1, R2, R3 cannot be in the same premises, or we can say cannot be used under one single LAN. This means R1 is one office, R2 is one office, R3 is one office. Until unless we enable HSRP between R1, R2, it might act as primary, secondary. But here in this case, R1, R2, R3 are three different routers or networks or offices. Okay. So for all these three routers, there is one internet link being connected for internet usage for the users. So that means browsing internet inside this network is like the users are going to access a public IP only for internet, not private IP. So 10 series and all are private range, right? Class A private series. So internet itself is on the public IP range only. So users might access any kind of websites, any URLs, but they don't know the IP address or predefined IP ranges. So in that case, we are going to enable a default route. Okay, default route is IP route 0.0.0.0.0. Next stop for this is 100.64.1.2. So 1.1 is this interface IP. 1.2 is this interface IP. So from this router, if you are going to enable a default route, it has to point to this IP only. This is the next hop IP, right? Directly connected interface IP will be the next hop. Yes. So I have configured for R1 with a default route. So that means any users connected behind R1 LAN they will be able to access the internet easily. But R1, R2, R3, these three are interconnected in OSPF and all belongs to area 0. So our requirement is for R2 and R3 users should also be able to reach the internet via R1 only. Okay. So there is no separate link connected from R2 to this internet or from R3 through to this internet. There is no separate link. So through R1 only, we are going to access this internet. So that is the requirement and how we are going to achieve that. So here in this example, we have given internet cloud and we have enabled a default route. But our requirement may vary from, from organization to organization where we need to access a specific file server to download or specific private cloud like AWS cloud, Azure cloud, okay, some cloud IP where we have hosted our server in the cloud. Okay, the requirement will be different from organization to organization in this example. But even though the requirement changes, the definition is this. If at all, if you want to inject any or enable a IP route, and if that needs to be reachable to the other routers connected in the same area, then the method is the same. Okay. So we have defined a default route in the R1 router. Okay. R1 we have defined. And at the same time, what we have to do is in the R1 router, we have to inject this IP route command or default route information, okay, to the OSPF as well. Only then it will start to publish it to the other routers in the same area. Okay, so what I will do, like yesterday we have configured OSPF, right? So router OSPF, process ID 1, it's already there defined on the R1 router. Network 10.0.0.0, just simply I'm telling, okay? 0.255.255. Yeah, area 0. Then I need to enable a command. Default hyphen information. This is just a command. Originate. So I'm just originating the default route on this router. So I'm going to publish or advertise whatever default routes added in the R1 router. I'm not specifically mentioning this route, but in general, all the default routes. So in this case, I've added only one default route. I can add multiple default routes, okay? One for the file server or one to access the cloud or the server hosted in cloud, anything. This is the command, that's it. So once you have published this default route inside OSPF for R1, that means it automatically says that to R2 router, in order to reach default route, you have to exit through R1. So for R3 router, in order to reach the internet cloud, your exit is via R2. So R3 will have a next stop to R2. R2 in turn will have an R1. So R3 users, they are trying to browse internet. For them, the next stop is R2 only. They will not know this IP, 64.1.2. They will not know this IP. Okay. So they will just go to R2 only. R2, in R2's routing table, default route pointing to the R1. So it will send traffic to R1. R1 only knows what is the exact next stop IP to reach internet. So internet traffic will have to move on multiple routes and then reach the exact firewall to exit. Okay, so what will be the output? Okay, what will be the output of R2? Now let's see what will be the output for R2. Okay.
Ma'am, hello.
Yes.
What I feel is if we enable NAT in R1, R2, and R3, we can translate all the private IP address into one public IP address and we can start using the internet
No, no, it is not
instead of.
translating. No, it is not translating anything. The translation like the NAT process is not translating anything. Okay.
I
Yeah,
did not
just
understand.
sorry.
I did not understand.
No, no.
What does it mean?
What is your question now? Just mention something like
Can, can we enable NAT in R1, R2, R3 so that it will translate those private IP address into public IP address and all the routers can access the internet?
okay. NAT translation can be done on any router, R1, R2, R3, but translation, see, only on R1 only the internet service provider is getting connected, not on R2 or R3. So in order to enable NAT, this R3 should have a separate internet. R2 should have a separate internet. At that time, you can do a translation. But NAT translation, again, see, it doesn't mean that we should not do NAT, or in this case, it is mandatory to do NAT. It is all optional. Okay. See, NAT translation comes like when the service provider has given you only one public IP. In that case, we cannot do any sort of translation because with one public IP, we can enable a default route. But we have purchased from the service provider some 10 set of IPs. Okay. So for that 10 set of public IPs, we can do a translation for the private range 10 series. Okay. So for any IP with 10.12, it should be translated. When it goes outside the network also, it has to be translated to the public IP and reach the internet. See, translation purpose is different. Why we need to apply a NAT is it differ for different purpose. Okay, for this topic, what we are trying to explain is how a default route can be injected to the OSPF process. If at all I don't want to use this default route to R1 and R2, R2 and R3, what will happen? R2 and R3 will still be in the OSPF network only. Users between these three routers will be able to communicate easily. No issues. But in my organization, I have three offices, R1, R2, R3, but I have a limitation where I can install the internet line which I have purchased, which is somewhat expensive internet link, okay, can be connected in only one office. Okay, is connected to one office, but I want to share that internet to the other two small offices as well. Okay, but at the same time, I cannot extend the link, share this internet link to R2, R3. That is not feasible, right? We're keeping that in mind, how we can make use of the internet line to all of my three offices together with one internet link that will actually optimize the network traffic, optimize the cost, optimize the bandwidth, everything. Mainly the cost. Mainly the cost. So why again they want to use only one internet? Because through internet, okay, through internet, if some users are going to access something, that is not going to be of for business traffic, right? For business traffic, users are not designed to reach internet. For business purpose, they are going to use only inside the routing which we enable between R1, R2, R3. Because inside office only, you'll have to communicate. R1 router is at one office having a file server, and R2 is at a different office having the database server hosted. R3 is in a different location where all the high-end virtual machines are running. Okay, so users behind these three networks have to intercommunicate with these three, like accessing the file server or VMs or databases, right? Because in one location we cannot host everything. Okay, not we cannot dump all the database, all the file servers or VMs. If we are going to dump everything on one location, then that location should have a higher bandwidth. It should be acting as a data center. Then high-end routers we need to install. We cannot invest in one office that much. If that office fails, then the other two users and all will be like connected to R2, R3 and all will be isolated. They cannot run the business. Keeping that in mind, they have installed separate, their applications in each of the locations. Okay, so for an organization, the main business is within their office only, not on the internet. But the users have been granted with internet access for certain things. If they want to browse, check something, Google something, obviously they need a basic internet access. For that reason only they have to use internet, not for business purpose. It is not at all required as per business or as per policy. It is not required at all internet. In many offices, they'll completely block the internet access itself. Users will not be able to browse anything on the internet except inside office network only they'll able to access. So at that time, they cannot invest more on the internet line. Okay, so that's why they have given only one internet line. But with that one internet line, how we are going to enable routing for R2 connected users and R3 connected users is what we have to see now. Got it now?
Yeah.
Okay. So with the just very simple commands, we are going to inject this default route to the OSPF process. So R1 as a direct link connecting to internet. So we have enabled a default route in R1. And also in the R1 OSPF process, we are injecting the default route with the help of the command default information originate. Okay. With this, the configuration part is over. Now, go to R2 and check the output. We are going to check the output of R2 router. Log into output, show IP route. Show IP route, what exactly will be the output of show IP route is nothing but the routing table. Whatever routes are being learned on that router and what will be its next op or directly connected network. That will be the output of show IP route. We initially saw this same in the IP routing basics, right? When I took the basics. So that is show IP route. So hit show IP route in R2 router. You will see an output of O*E2. That means OSPF enabled an external route. E2, external route. Okay, via an external route, this route is being learnt via 10.12.1.1. So what is 10.12.1.1 is this interface. 10.12.1.2 is this interface IP. Okay. 1.1 and 1.2. So from this router, it means a default route has been learned, and for that default route, the next hop is this interface 10.12.1.1. Okay, for this common link, this is the IP range, and 1.1 is assigned over here and 1.2 is assigned over here. So 1.1 is the next hop IP to reach the default route or the internet. So that is the output. Got it? So R2 router does not know this IP at all. Okay. R2 router just sends the default traffic to this interface. That's it. From here, there is already a default route in R1. It is going to push the traffic to the internet cloud. That is what the R2 is going to do. For any router of that matter, network traffic will be sent only to the directly connected interface IP only. That is called as next hop IP for any segment. Okay. It will not divert the traffic directly to 100.64.1.2. That is not possible. It has to be a directly connected next hop. Only then it will try to send the traffic. Okay. Got it? Similarly, when you check for R3, what will be the output on R3? Let's see. For R3 also you will see an OSPF external route. A route learned via OSPF external routing, okay, via 10.23.1.2. 10.23.1.2, right? 1.2 only, right? Yeah. So this is 1.1, this is 1.2. So from R3, a default route is learned on this interface. So any default, any user from R3 wants to access an internet, it's going to push the traffic to this interface. As this interface IP is configured as next hop. So it's going to push the traffic over here. Then that particular packet will check for the routing table. It's a default 0.0.0 IP. For that, which will be the exit IP or exit interface, it will see 1.1. Okay, 1.1 is here. Okay, it will send. Again, for the same network packet, so the destination will see, okay, default route is my destination. 0.0.0. Anything inside 0.0 should go to which next interface? This interface. Then it will give the traffic over here and reach the internet. So it has to pass on each and every router and then go reach the internet cloud. So this is with very simple command. We have injected one default route into OSPF network so that the same has been advertised inside the same area so that all the three routers are being benefited by the internet. Okay, so this one is clear.
Yeah.
This one is clear.
Yes, ma'am.
Okay. So next topic we actually see about the DR router election process. Okay. So so how DR and BDR as being elected? That is the designated router and the backup designated routers, how it is being elected. So during the OSPF neighborship process, when it's going to establish the OSPF neighborship, so specifically in the phase of two-way. So we have seen different states of OSPF, right? Down attempt in it, two-way. So at the stage of two-way only, the actual election process takes place. Or at the state of two-way only, the actual router OSPF process will check if there is any priority is being configured on the routers so that it can match with the other neighbor router and elect a router as or agree with all the neighbor router for the election of DR and BDR. So at the state of two-way only, this process happens. So at that time, what happens? The hello packet includes the router ID or the OSPF priority. Okay. So OSP, we are going to configure one additional command after OSPF process 1. We are going to configure one additional command of OSPF priority, setting the priority for the OSPF. Okay, so that is nothing but with the command set manually IP OSPF priority. And this ranges from 0 to any number between 0 to 255. It can be 1 or it can be 255 or 50, anything. Okay. So we are going to, so again, like I said yesterday or in the previous classes when we discussed about OSPF, the DR and BDR election is a manual process. It's not automatic. It's not automatic. We want to decide which router wants to be a designated router, which router has to be as a backup designated router. Okay, it's the network administrator who's going to decide. So we are going to set the priority for the OSPF process on that router if that router wants to become a DR. Okay, by default, if we are not going to configure any priority, the priority value is 1. Okay. So in the previous day, we have seen see priority 11111, priority 111. That means we have not set any priority. So by default, it is taking the value 1. Okay. Now, if you are going to want to set the priority, then we are going to use this command IP OSPF priority and configure that router in priority 1 or 255. Priority 1 is the least, okay, and any priority above 1 will be the highest one. So highest priority will be elected as DR. Okay, highest priority, sorry. Lowest priority will be elected as, yeah, so it's vice versa, sorry. Any priority with value 1 will be the DR, and any number more than 1, 2 or 3 or 100 will be the backup designated router. Okay. So, yeah. So once the router, so what process actually the router follows is, so routers receives this priority information in the allow packet itself. When the router is sending allow packet, we have seen, in the allow packet, let me show. Router ID. Yeah, router ID and all will be there. So in that allow packet itself, by default, OSPF uses this priority and router ID in the allow packet. So when the router receives this hello information from the neighbors, it is going to identify itself initially as the DR. And then it is going to send a hello packet, because that router does not know, right? Is that router is going to behave as DR or BDR. So initially it takes that it is a DR, and it's going to send that hello information to the neighbor. Once it receives the hello packet from the neighbor, at the neighbor's end, the hello in the hello packet, the priority is set, right? So if the priority is set to 1, and for its own router, if the priority is set to 100, then the router will wait. Okay. Similarly, it will wait for other neighbor routers also to send the hello packet, where it compares the route priority ID, priority information in all the hello packets, and mutually all the routers, okay, will be favorable with the higher router ID or higher priority, and it will be elected as the DR. So this DR election and all is happening in the two-way neighbor state, actually before the XStart state starts. So down, attempt, init, two-way, XStart, exchange, and what is the next stage? XStart, exchange, and full adjacency, right? So at XStart state, before the XStart state starts, actually this hello packets being exchanged. If at all the priority is set, then the DR BDR election also takes place, and it is getting finalized which router is DR, which is BDR. Okay. And then it moves on to the next state in the OSPF process to form the neighborship. Okay. So I'll just give you an example, an output example. Okay, so this is how I'm going to configure on router 1. And inside the interface, gig01, I'm setting the priority, IP OSPF priority 100. On router 4, interface gig01, IP OSPF priority 0. Or it can be 1. 0 means it is a DR other router. DR other means it is not going to participate in the DR or BDR election at all. Okay, that is 0. So I'm manually letting this R1 router should not participate. So I'm setting it 0. I want R1 to be elected as DR, so I'm setting it as 100. So if you see show IP OSPF neighbor, so you will be able to see why I have not configured IP OSPF priority 1 in any of the router. I have shown only R1 configured with 100, R4 configured with 0. I have not configured any router as DR or value 1. Why? Because by default, any router's priority is 1. Okay. If any value higher than 1, okay, will be considered as BDR. So the lower the value is the best router elected for the best router elected as DR. Okay, so I've set a higher priority for R2. For R4, I have set a 0 priority, telling it should not participate, DR other. So automatically router R2 is being elected as DR. So 192.163.3 is the IP, and that is elected as DR. Got it? So one router, manually I'm setting it to BDR. So likewise, I can set any number of BDRs. But in one OSPF process, there should be only one DR, designated router. and multiple BDRs. Why we want to do the selection? I mean, it is not mandatory for DR-BDR election. I can still run my OSPF process. But why do you want to go for a DR-BDR election? Is when the OSPF is like advertising or updating the neighbor information, sending packets to and fro inside the OSPF network. At that time, for any link state change, or any link is getting added, or link is going down and it's coming up, for any sort of changes happening in any specific network or router, the updates are going to send to be each and every router. R1 is going to send to R2, R1 is going to send to R3, R2 is going to send the same information to R2, because from R2 is saying, okay, I have an update from, it's going to send the same update to R3. So likewise, there will be too many update packet is being sent in order to avoid and improve the efficiency of the router performance, right? We are electing one router as TR. So for any network change happens in the OSPF, from that network, for if R1, from R1, the update goes to the DR only, not to the any other routers in the OSPF process. So it goes only to the DR. And in turn, DR sends to other routers in the OSPF, right? So any change in topology is being reported only to the DR router, and DR router sends that updates to all the routers in the OSPF. This way, actually, we can improve the efficiency of the router. Apart from this, the routing is not going to be impacted. Routing we have enabled between multiple networks and all, right? That is not going to get impacted with the DR-BDR election. So that is a different process. This is only when we are going to send updates, receive updates. At that time, we are just minimizing the workload of the router. Minimizing the workload of the router, which helps the router to perform much better. Because OSPF protocol itself has a lot many features. It's not like EIGR or RIP. Okay. The load on the router is huge. Processing speed to run the OSPF is also like a bit higher when we compare to the other routers. So we want to save some processing, okay, for the OSPF routing level. So we want to save something. Just we cannot use everything just to send receive updates or during the network convergence. So that's not going to work. So clear with this DR-BDR election?
Yeah, yes, ma'am.
Okay. So if you have any doubts in any topic, you can ask now.
Yeah, actually, I want to know what is SD-WAN, SD-access.
What is that?
SD-WAN, SD-access.
SD-WAN. SD-WAN is completely a different topic.
Yeah, I know, but I just wanted to ask.
Maybe I'll get back to you. It's again a separate topic. SD-WAN. It's what to say, a new technology introduced for the new WAN technology, we can say. Okay,
Okay.
earlier it was Ethernet. Okay, Ethernet with what to say, with fiber and all, with fiber connectivity. Okay, this SD-WAN is completely a newer technology introduced like when I started to know about SD-WAN is at the year of 2019, I guess. Okay, only at that time, 2019 only, they started introducing this SD-WAN technology on the WAN end. So, like, so far what we are seeing is the routing between the routers only inside the office. but how the routing should happen outside to a different, with a different AS, with a different AS
Mm.
using the BGP. Okay.
Okay.
With that,
Mm.
how we are going to use that routing, that new technology is SD-WAN technology. Okay.
Mm-hmm.
So that is a new one. I'll explain you. Okay.
Yeah. Okay.
That recently has come. So 2019 to, so it's been 6 years now. Okay. It's a new technology introduced, and all the offices are now migrated to from fiber and all. They moved to SD-WAN nowadays. So in 2019 itself, we started to migrate all our links to SD-WAN with the help of the service provider, because for all the routers, we have to purchase a service provider link in order to have an internet communication. I have an office in, say, I have an office in India. I have an office in Singapore. I want to enable a network connectivity. How I'm going to, simply I cannot run EAGRP OSPF enable network connectivity. But from my office in India, I have to connect to Singapore means there are multiple service providers in between establishing the physical connectivity. It's not going to be over wireless or satellite communication, nothing. Okay.
Mm.
It's not a wireless or satellite communication. It's a physical fiber cable connection between the offices, between geographical location is happening. Satellite connection is going to be very costly, very expensive, and at the same time we cannot rely on the technology where there might be data loss due to the geographical condition, nature condition and all. So satellite and all is not reliable, only direct physical connectivity. So we have many fiber cables running underground or under the sea. Many fiber connections are running. With that cabling, which was laid from the service provider end only, we are getting connectivity to different offices. So in India, I have a link purchased from the service provider, from say BSNL or Jio or Reliance. I
Mm.
purchased the internet line, or Orange or AT&T. They are all internet service providers only. Okay. So for BT in British Telecom and all are from European regions, So purchased a internet line. They will have a direct physical connectivity enabled, routing enabled, with again as a next top service provider. Likewise, many service providers will come, or what will happen is like, say Orange is the service provider which is giving me the internet line. Same Orange will be located in the nearby location. From India, I want to go to Singapore means, what are the best path I can choose from Nepal, from Thailand, or what are the other ways where I can go underneath? Yes, I go to Sri Lanka, underground, undersea cable, I can directly reach Singapore. So in Sri Lanka, there will be an Orange provider. So they'll have a connectivity from Singapore, from Sri Lanka. There will be a fiber cable running inside the sea, which is directly getting to the Singapore main office, Orange providers router. So from there it will go to, so this is how it happens actually. Okay, so it is a very vast thing when it comes to enabling routing. We from our office, what we do is we configure a router and we purchase a link from the service provider. We configure with their IP address as a next stop, enable routing EAGRP, OSPF or BGP, anything. We know what is our directly connected next stop, directly connected service provider only. From there, like what I've explained, no, R2, R3, likewise, the communication goes on and on and on to reach the exact destination for us. So it goes. So it is all physical connectivity only throughout the world actually. Globally, it is done this way only. Because when I came to know about this is like when I was working In Africa, there was a cable cut in the sea, a fiber cut, a major fiber cut under the sea happened, and this actually impacted all the African offices. Okay, all the African offices were disconnected from the network completely because we don't have any other alternative link, and that fiber cable is acting as a single point of failure. So we don't have a backup link also. So at that time only, in order to like recover the link, and we have also enabled with the help of the service provider. It's not our office did not work individually. With the help of the service provider only, we added an additional link purchased with the most expensive link, an alternative link, so that even if one link fails, the other should take over the traffic. So that's a very big concept actually. So that time only I came across this fiber, undersea fiber cable running, and the single point of failure which happened, which disconnected many multiple offices, got isolated. So with that knowledge only I'm telling you.